Hey, howdy, hey everybody. It's Stig here in the studio, and in today's episode of Grand Slammin' Towards STAAR, we will be reviewing 2D geometry. So without further ado, let's go ahead and take a look at our 2D geometry cheat sheet. First up on this cheat sheet, we do need to review the process for calculating the area of some given polygons. So the first type of polygons we see here are triangles, and we need to recall that the formula for area of a triangle is 1/2 the base times the height, or in other words, the base times the height divided by 2. So remember that multiplying by 1/2 and dividing by 2 are the exact same thing. So that means that although these two formulas look very different from each other, they are actually doing the exact same thing. Now, the second set of polygons we have here are quadrilaterals. The first quadrilateral we see here is a rectangle, and the formula for calculating area of a rectangle is A equals BH. The next type of quadrilateral we see here is a parallelogram, and the formula for calculating area of a parallelogram is A equals BH. Or in other words, the area is equal to the base times the height. And the third and final type of quadrilateral we see there is a trapezoid. And the formula for calculating area of a trapezoid is A equals 1/2 the quantity of B1 plus B2 times the height. Or in other words, the area is equal to 1/2 times the quantity of base 1 plus base 2 times the height. All right, moving right on to circles. So first up, we have this arrow pointing to this outside edge of the circle, or in other words, the distance around that circle. And we know the distance around the circle as the circumference of a circle. Now, remember when we're taking a look at circles, a line that goes halfway across our circle, like we see here, is our radius. And a line that goes all the way across that circle, like we see here, would be our diameter. Now, when it comes to circles, we've got a few different formulas that we might use. First up, we've got the circumference formula. And the circumference formula states that C, the circumference, is equal to pi times D, the diameter. We also know that there's another formula for circumference that states that C, the circumference, is equal to 2 times pi times R, the radius. Now, if we're asked to calculate the area of a circle, the formula for calculating area of a circle is A equals pi r squared. Or in other words, the area is equal to pi times the radius squared. Now, something else we might want to bring to our memory is that if we need to calculate the diameter given a radius, we know that D, the diameter, is equal to 2 times the radius. Now, what if we're given a diameter and we need to find the radius? Well, we know that the radius is equal to 1/2 the diameter. Then it states that the area of a semicircle can be found by dividing the area of the whole circle by 2. And then they want us to know that some equivalent values of pi would be 3.14 or 22/7. All right, now let's take a look at composite figures. So a composite figure is a figure that can be decomposed into basic shapes. So, for example, I have this arrow here that can be decomposed into a rectangle and a triangle. I have this figure here that can be decomposed into a parallelogram and a circle. And then I have this track figure here that can be decomposed into a rectangle and two semicircles, or in other words, a rectangle and one whole circle. So in order to find the area of a composite figure, we first need to find the area of the various shapes, and then we will add or subtract based on the type of problem we're working with. So if we're asked to calculate the total area, like we might be in these two figures here, then we would add. If we're asked to calculate the area of the shaded region, like we might be asked to do with this figure here, then we would subtract, okay? So again, for example, if we were asked to calculate the total area of this composite figure here, we would calculate the area of the rectangle, calculate the area of the triangle, and add those two areas together. Here, if we were asked to find the area of the shaded region, we would calculate the area of the parallelogram and calculate the area of that circle, and then we would subtract the area of the circle from the area of the parallelogram. And finally, if we were asked to calculate the total area of this figure here, we would first calculate the area of the rectangle, and then we could either calculate the area of two semicircles or just calculate the area of one circle, since those two semicircles are exactly the same and two semicircles make up a whole circle. Then we would add the area of the rectangle to the area of the circle. And last but certainly not least on our 2D geometry cheat sheet, we need to take a look at angle relationships. So the first angle relationship we need to take a look at is the relationship between the angles in a triangle. So the three angles in a triangle have a sum of 180 degrees. So if I were asked to calculate the value of the missing angle here, I could say that x plus 75 plus 33 is equal to 180, since these three angles have a sum of 180 degrees. Now I would combine like terms. 33 plus 75 would be 108. So x plus 108 would be equal to 180. Now to solve for x, or in other words, to isolate my variable, I need to go ahead and subtract 108 from both sides. X plus 108 minus 108 would just leave me with x. And 180 minus 108 would give me 72. So the measure of that missing angle would be 72 degrees. And I could add 75 plus 33 plus 72 up together. And when I add all three of those values together, it should be equivalent to a total of 180. Now let's review complementary and supplementary angles. So some complementary angles from this image here, or from this graphic here, would be angle DBE and angle EBF. So DBE and EBF, we can see that those two angles together create a sum of 90 degrees. So that means that complementary angles have a sum of 90 degrees. And a pair of supplementary angles in this example here would be angle ABC and angle CBF. So ABC and CBF, I can see that these two angles together create a straight angle, which has a measure of 180 degrees. So that means that supplementary angles have a sum of 180 degrees. And as you can see, this does bring us to the conclusion of our 2D geometry cheat sheet. So that means that that's all I've got for you over 2D geometry. As always, if you have questions or you need some additional assistance with the information that we have covered today, please feel free to reach out to us. We are here for you and more than willing and more than happy to help you out. Other than that, guys, I hope you have a fabulous rest of your day, and we look forward to seeing you soon. For now, this is Stieg signing off. We'll see you next time.